Here's the startup procedure for the drain it every night hybrid solar powered water heater. First step, or some of the steps: shut this drain valve. Next, hook the pump up, which has been removed every night, put in a warm place so it doesn't, residual water that doesn't freeze up. Quick couplers here, snaps in there. It's the return line. It's the output. Another quick coupler. Snap that in. And shut this valve. Next is go up here on the secondary heater, shut the drain valve, and I think that's it. You can start to fill up the tank, which is going to fill up here. So while the tank's filling, the water's coming. This is the sight glass. This will show where the water level is in the tank. It takes a while because it's going to fill up here. It has to come up. The heating coil is about right here, so I need to put in like up to here at least. But if I have a lot of sun, I can fill it up to here. So that'd be about a third of this 50-gallon tank. And then the way this works is the pump pumps up this line, which goes back up to this little tank on top. It's going to fill up this tank here, this little tank, and then when it's full, it comes out of this, it comes out of here, goes back down here, down into the big tank below. So then it just falls down in this tank, and then it recirculates through the bottom here, goes out here, back down into the pump again. So it recirculates. So I redid this. It was all garden hoses last year. I tried to pitch everything. I used PEX, and I had to cut them all off and redo them a few times. Here's the controllers. Right now, this power from the solar panels outside, the direct DC, is going into a resistance heater. But I'm going to shut that off. This is the main DC coming in. You'll probably see a spark here. Little bit of one, so I broke the load. So now I'm ready to, when I'm ready, I'm going to turn it on and it'll heat the water. Let's see how this fill up's going. Here it is. See, the water level's up to, I have to get at the right angle here to see it. There's the water level. There, you can see it there. That tells me the water's up to here now. Otherwise you'd never know how much is in there. So what I'm going to do is turn the pump on just to fill up the top tank. For right now I just have to manually plug it in. Let's see if it goes. I'm going to turn off the main water pump. So if all goes well, this little pump is going to pump up to this pump is going to pump up to the tank on top. This is an old washing machine pump out of a washing machine. And it's making it up. It's going up this one over to here. You can hear it filling up. So this one needs to fill all the way up to the top, and then it'll force it out of here back down into this tank. Now I'm going in, I'm not going in what would be the normal cold, because the normal cold would here's the deal with these tanks. Let me get back here. This fill tube on the normal cold comes all the way to the bottom of the tank. There's like a tube down here, comes down to the bottom, and you know, normally you would put the cold in the bottom, the hot rises to the top. This normal hot one just has a little tube, so but for the way I'm doing it, the other day there was a little bit of residual water at the bottom that didn't drain out, and the tube there must have froze, so it wouldn't fill back up. So I'm just dumping it in the top. It doesn't make any difference for what I'm doing because I'm using a pump and recirculating it. So it fills up the top, and it'll the pressure from the pump will still force it out of the top like we need. There, it's full, because I can hear it. I can hear the water coming through here. So since I have enough water over this heating coil, well, I need to shut this valve here. This is just the top of my fill line. Since I have enough water in this over this coil here, you turn those heaters on before there's water in and they burn out, so you can't space that stuff out. So I have enough water in the tank over that, and I know this one's full, so I can turn the heating valves on, which I do with this switch, and that turns these on, and they're both calling for heat. The little red LEDs say they're closed. This one controls this solid state relay, which comes from the battery inverter. This side here controls this IGB block, which is the direct DC. This heating coil and this small heater here is the one that comes from the battery. It's a 2000 watt, 120 volt. And the one in the big heater here is the direct DC heating coil. It's also 2000 watt, but it's rated 240 volts. So it matches my DC better. Right now, if you can read that, it's 532 watts in, 123 volts on the direct DC side. I'm not getting any power from the other heater because these batteries are not filled up yet. And this controller over here, this solar controller over here, is going to be the one that tells this relay over here when to turn on. And it won't do that until there's extra power in the batteries, which will be in about an hour or so, maybe less. So the sun is just hitting the panels pretty good now. This is the direct DC. I got a little bit of shading on these panels here. from my other solar array, which wasn't good planning, but pretty soon the sun will be up and it won't matter anyway. So that's the startup procedure for this. The only other thing I didn't mention is that I won't leave this pump plugged in direct all the time. I'm going to unplug this here, and that gets plugged into this outlet. This outlet is controlled by this this differential controller. It has two temperature sensors. One goes to the small tank. There's the wire going in. It's telling the temperature of this tank. And there's another sensor that goes in and tells the temperature of this tank. So what it does is when this one is hotter, when this little tank, the water's hotter in here than the one down below there, it turns the pump on, circulates the water. Right now, the top tank is almost 45 degrees Fahrenheit. The other tank, you can see it's flashing there, that's symbolizing the lower tank. That's 47 degrees, so this has to be hotter than, as soon as it gets like 1 degree hotter, the top tank gets 1 degree hotter than the bottom tank, it'll turn on and circulate. It works real well. Works pretty well, except at the end of the day when it might run a little bit longer than you want it to. But it works okay. It's pretty much automated in the pump, so and it circulates the water so that you don't get, otherwise if you just had a heating coil in here, what happens is the water will stratify and it'll heat up. The hot water will come up here, but the water will stay down cold here at the bottom because it's below this heating element. Heating element's here. It would heat up the water. Water rises. Temperature sensors here. If I had it down here, it might work better, but then the pump circulates, so it keeps this all the same temperature. Anyway, that's how it works. At night I need to use the water and I drain some extra out, drain it all out, but start over again like I just did. Just to check the water level now. It's hard to see in the sun. There's the water level. You can see it. So the water level's here. Since it's a good sunny day, I'll probably add a little bit more water in there. It'll all heat up. In summer, the system's totally different because I can fill the whole tank up and have plenty of hot water all the time. Don't have to worry about it freezing. This is the winter system. Anyway, hope that wasn't too complicated and you enjoyed my convoluted hot water heating system. An hour later,